Testing the Reedy Sonic M3 motors, which I'm told are really fast, and you can win A finals with them without any problem. This is the 17.5. I've got a 17.5 turn standard one and the 1S one. Also, if I get time, I've got one of the alternative rotors. This is a small diameter one. These will have about 12.45 in them. There is one, I think, about 12.25, and this is the 12. So I will test it with that as well. I'll do all the tests, measure and test in them. I'll set them up on this analyzer. I've taken the two motors out of the boxes, and you've got the normal one and the 1S one. They look identical, the writing on them is identical, except for what's written on the end of the rotor. And this one says 273, which is the normal one, and on the 1S one it says 272. Now, Reedy does an option of 3 rotors for these motors: the 271, 272, 273. 273 being the largest of them, 12.5 nominal diameter down to the 12mm diameter there. So this one's going to be lighter than the standard one, and the gauss will probably be lesser. They don't tell you the gauss, they just say for fine tuning. Anyways, I've got a gauss meter, so it won't be a problem if you take it out and measure the gauss. So that's so far the differences between them are 2 different rotors. The stack lengths you can see through these windows, and they look identical, stack lengths through the windows without measuring them. And then the weight, the standard one weighs 175.5, and the 1S one weighs 172.4. And I've got a chart here which I've used previously for writing down all the information. I've checked the Fantom, the Motiv, Revtech 24K. Now I can do the Reedy standard one and the 1S. So I can write down the results, the rotor numbers, the weights, and then I'll do all the time in the amps, kV, RPM, resistance, all that, and write it on here for you. I'll take it apart, measure the gauss, measure up the revs, amps and everything on this tester. And also, if I've got time, I've got a dyno which has a flywheel which I can spin up, and I can put all the results onto the computer and measure horsepower, torque, efficiency and amp draw versus revs and or time. I can do it takes a lot more time to compare these, but if I've got time I will spin them up and put the results on there as well. Timing as supplied, they're both at 30 degrees. There's a tiny little mark, it's very hard to see, but anyway they're both at 30 degrees. Timing on the standard one as supplied, it says 30 degrees on the M bell, but it's only 22 degrees on here, but very tight. 21, 22, 23 is a good sensor board. Timing on the 1S version, also 22 degrees it came out, and another tight sensor board, 21, 21, 23. Adjusted the M bell to get the amps to 6 amps. It's doing 2924 kV, which isn't particularly high. This is the high strength one, not the 1S one. Timing when set to 6 amps, optimum is 48 degrees average, and the spread 47, 48, 50 on the standard rotor. M-bell timing is about 48. Right, this is the 1S one. It's got much higher revs and at the 6 amps mark, and that is due to the rotor, which must have less gauss. So I'll just do the timing for you. Timing's 48 degrees on this one, the 1S, the same as the other one, to achieve the 6 amps. And the N-bell, the timing sensor spread's still good. The timing on the actual M-bell markings is, it's about, the little marks on about 45, halfway between 40 and 50. The graduations only go up to 50 degrees, by the way. Here are the parts from the 1S one. So it's got the smaller rotor. It's got it written on it, the size, which is 12.2. Anyway, let's measure the gauss. As you can see, it's basically 1300 one side. Not the same both sides. So most rotors these days seem to be about 1400, so this is reasonably low. Will reduce the torque, but maybe it'll suit the motor. And check it says it's a 12.2, and it's close enough, 12.19 say. Here's the rotor number 273, which has got 12.5 on it from the standard can. So we just check the gauss, 1400. So it's 1400. So and on the other one it was say 1300. So taken the stators out of the two motors, the 1S and the 2S. And there is a difference if you look at them side by side. The wire on this one, the 1S one, is pushed in more. This one sticks out. So I haven't actually measured the resistance yet, but there's a difference. And also if you put them side by side, I'll put a caliper on it, but it looks like the 1S one is fractionally shorter. Anyway, weighing it, 111.4 and 109.6 for the 1S. So there is a difference. So let's measure the stack length. It's 19.76. 20.28, so it looks like there's one lamination less on the 1S one. Now measure the wire resistance next. Checking the winding resistance of the 1S Reedy. The charts, I know that a typical 17.5 is 0.045. And they generally are all about the same. The copper wires on all these motors, different makes, are around about the same. Yeah, 0.045. So I'll check the other one will be the same, the M1, I'm sure. I've got the AS254 here. Just going to check the winding resistance on this one. 0.44, 0.45, same as the other one. While the motors are apart, I might as well fit say the standard one with this 12mm optional rotor and measure the performance with it. Here's the optional 12mm rotor, 12.0, and on there it's got a number, it's got 271 written on the shaft end. Let's measure it. 12. I guess they wanted it to be 1250. So it's 1250, 1260 say. Here's the standard can with the 12.0mm rotor put in, and set it up so it's reading 6 amps and it's doing 3422 kV revs per volt, which is a bit higher than it was with the 1S1, which had the other rotor in, but there's not much difference. Let's measure the timing. Timing is an average of 47 with a 46, 47, 48. Right, I finished the tests on the Reedy Sonic M3 motors, 17.5 turn. The two versions, the 254, which has the higher gauss rotor, the 269, which is called the 1S, which has a medium gauss rotor, and I've also tested it with the 12mm low gauss rotor, which I put in one and tested it. Put all the results down on this chart, and also on this chart I've got the results from the other motors I've tested, such as the Fantom 17.5 Type M, the Motiv M Code 17.5, the Revtech 24K Gold 17.5, and I've got the results for the 3 Reedy motors. So looking a bit closer at the results, first things we notice on here is, if you look through the video, I set up the amp drawer on my tester to 6 amps to do the comparison. It has to be exactly 6 amps, otherwise the comparison's be no good. And the figures we're going to look at are the kV and the timing. And the kV, you have to set the amps dead accurate to get the kV reading. If you set it at other amp drawers or voltages, it won't be comparable. So, having a look at this chart, get it a bit closer for you. The 3 Reedy ones, let's have a look at them. The 3 different rotors, as I've said. Now the first one, the 254, has the strongest rotor in it, and of course it has the lowest revs. Quite low, 2,887 kV or revs per volt at 6 amps. I checked it twice to make sure I had the amps set correctly, so it came out about 2,900. These other figures, by the way, is I put a flywheel load on to compare. It didn't really give me any interesting figures, so I didn't continue with that. And also the results from the complete dyno test. That will be in another video, as it takes up much too much time to put it in one video. So these figures though give us plenty of information about these motors. As I said, the standard one, say 2,900 kV. The 1S version with the medium rotor, as the revs really leap up. They say it's short stack as well, and we did find it's 1 lamination shorter, but that isn't very significant, 1 lamination. Anyway, 3360, really good revs. And then with the low gauss rotor, which I put into the 254 can, the revs jumped up again, 3422. Now revs on their own are not that useful. The kV, if the timing's way out, you want the timing to be as low as possible with the high revs. If you've got very high timing and high revs, that means your rotor's going to be weak, or you've turned the amps up very high. So the lower the timing to get the revs at the amps, the better. Now 48 degrees this for these two, 47 for this one, which is even better. Comparing it to the other motors up here, we see that the Fantom, which is a really good motor, 3108 at 6, has a 50 degrees timing on the end bell. The Motiv, that's got the really strong rotor in it, so the revs are very low, 2765 kV, 50 degrees. And the Revtech, which is also a good motor, 3079, just fractionally below the Fantom, 50 degrees. So as you can see, the standard Reedy Sonic is right up there with these, and the 1S version is a very revvy motor, which means it's going to be ideal on high-speed tracks, and also for actually for your 1S cars, 12th cars, etc. And this one, with the even smaller rotor, looks like it's going to be excellent on very big, fast tracks with very long straights. That one, if you gear it right, it's going to be excellent. Now looking at the rotors, as I said, there's 3 rotors. They're coded 273 is the strongest, 272 to 271. The Gauss in the video on this one was, I haven't written it down, but it was about 1400. This one was about 1300, and this one about 1250. Now 1400 is pretty standard for instance the Revtech, just over 1400, and the Fantom, same, about 1400. But the Motiv was a whopping over 1500 Gauss. Very strong rotor, that's why it's got low revs, and it'd be very torquey. But you can't gear this up on very high speed tracks. Well, you can, but it'd be very inefficient because of the power required to rotate the torque. The torque resistance of the rotor will absorb a lot of power, which won't be used to propel your car, will be used just to turn the rotor, and which will be lost as heat. So it's not the best motor for big tracks. Very good for very small winding tracks, lots of acceleration out of small corners. Again, you've got to gear these motors right. You just can't gear all these motors up higher and higher and expect to go faster. You'll make them very inefficient. They'll get very hot. Anyway, so those are the rotors. Now, a few other interesting pointers here. We've got the total weight of the motors. The readers are quite heavy, 175, 172, 173 grams. They've got quite heavy duty alloy cases on them, strong. I think that's where the weight's going, because if you look at the stator weights, that's the wound part and the laminations wound. Inside, they're all very similar, 110 grams, 107. I'm sure this was the same, I haven't written it down, 111, 109. So the weight, the extra weight here is coming from the case design. We know the Motiv's got a very lightweight sensor end bell. It's very small, to save some weight there. So there's over 10 grams saving if you want to use, or about 10 grams if you're going to use like the Fantom and the Revtech over the Reedy, if you're trying to save a bit of weight on your motor. Other important facts, I said done the rotor winding resistance. Well, the standard winding resistance of a 17.5 turn on all good motors now is about 0.044, 0.045. And if you look at these, the 1S version, which we looked at, was wound very neatly by whoever wound it, and then 0.044. nice and low. The other one 0.045. I don't think that's got more. It's not because it's particularly short. It was wound very neatly. This one. The lower the resistance, the better. It means less losses in the winding, less heating, more current can pass. The Revtech 0.044, the Motiv 0.044, and the Fantom, well, 0.045. It's close enough. They're all about the same. So, which motor to choose? Well, definitely, if you had a massively high track, constant high speed, this Reedy with the optional small rotor, I think will be maintain the best top end. Small tracks, Motiv, and all the other tracks. We know the Fantom is very good motor. It's very efficient. It's got the best stator material, and it's a reasonable weight. So all these motors are very good, but the Reedys definitely edge it on revs. Very revvy motors, and they're the only ones actually that have different rotors. Some of the other motors I've tested that have 1S variations, such as the Fantom 17.5s, they use the same rotor, and the differences are very small. The rotors make the biggest differences. So any of these motors can win you A finals, but on the bigger, faster tracks, I wouldn't use the Motiv. You'd have to overgear it, running efficiently at high speeds. And one of these, the 1S version, looks like the best, and the other one for very high speed tracks. But I think you can win with any of them. So that's all the results, and I will be doing a video if I can, graphing these up on the dyno to show the peak power and the peak efficiency points, and how to gear them, but that is quite a complex video, and I'll be doing that as a separate project.